Alright guys, so basically what we're going to do, we're going to work out the pressure loss from the design points back to the C gauge, right? So that's from DPF first, which is the furthest away design point, and we want to run the pipe all the way back to the C gauge, which is here. Having a quick look at it, you've got your installation control valve here with a gate valve above, because it tells you here. You don't need to worry about the bypass because that basically doesn't come into play. So you get a 3 metre rise, 110 metres, 15 metres, rise it up, and over to the design point. Now I'm not going to size the ranges, but we are going to size the mains from design point F back, and we're allowed to lose half a bar according to the rules. Okay. So using an Excel spreadsheet, we just get started. So the first thing we want to do, we want to work out how much pipe and fittings we've got here. So we're going to do the quick guide. So basically, if we look at it, we start from here, we've got 3 metres plus 110 metres plus 15 metres plus 5 metres plus another 6 metres plus 2 metres plus 3 metres plus 3 metres. We've got 147 metres from C gauge to the design point F. Okay. Now we want to put provisional sum for fittings in. And remember, I'm putting 3 metres as a standard. So fittings, we have a gate valve, which is 1, an elbow 2, an elbow 3, an elbow 4. We're not turning in that T, so we don't include it. An elbow 5, so we'll get 5. Okay, so that would be 15. My overall total is 162. Okay. Now in the question we're trying to get 480 millibars, so we put here 480. And then we'll do a quick sum. So the millibars we can lose, divide that by the meterage we've got, will tell me I can lose 2.96 millibars per meter. Okay. So we go down here and we say, right, okay, can we use 4-inch pipe? No, because that's 4.4 millibars per meter. 4.4 is more than 2.96, so we can't use all 4-inch pipe. So we're going to have some 6-inch pipe. Okay, so if we run it all in 6-inch pipe, so it'll be 480, 162, which is my length of pipe fittings. So my pressure loss there would be 162 times 65. So if I ran it all in 6-inch pipe, I would be at 105 millibars overall for pressure loss. Okay, that's fine. So what I've got spare is 480, which is my target, minus what I have with running it all in 6-inch pipe. So I get 347 metres. So what I'm basically saying here is then that, right, okay, I've got 347 millibars left. So I want to see how much 4-inch pipe I can run in that. So equals 374 millibars divided by the millibars per metre in 4-inch. And that tells me I can run 85 metres of 4-inch pipe. Okay, great, that's a starter for 10. Right, so we need to measure it up. So we've got 3, 6, 8, 14, 19, 29, 34 metres. So I'm going to be changing somewhere along here. Okay, so my 85 metres is in here somewhere. Okay, so we'll just make a start. So we'll put in my spreadsheet here 85 metres. Okay, now if we run through this, we don't have any 45 elbows. We've got some 90-degree elbows, so we've got 1, 2, 3. So 3 90-degree. So 3 elbows with equivalent length equals off of table 23, 90-degree welded elbows, 4 inches, 1.4 metres each. So it's 3 times 1.4. Okay, it's 4.2. We're not turning in any T's, we've not got any gate valves, we've not got any butterfly valves, no globe valves, no non-returns, etc, etc. So my total length, including equivalent lengths of elbows, is 89 metres. Okay, so we then times that by 4.4, which is millibars loss per metre, and that tells me I'm at 392. Okay, right. Now, we knew, looking at this, we were 147 metres. Okay, so quick calculation here, 147 minus 85 leaves me a balance of 62 metres from here. So up here, 62 metres, and at that point we change to 4 inch. So we look at here and we say, have we got any elbows? Yes, we've got one at the top of the riser. So a 6 inch and a 150 diameter 90-degree welded elbow equals 2 metres of pipe. So we'll put that in. Any T's, we're not turning in a T. However, we do have a gate valve at the top of the ICV. Right. So the gate valve itself comes to 101.1 metres. Right. We don't have anything else in there. So 0.65 is a millibar per metre loss. Okay. So we're sitting at what we've basically got here. We want to put in here what we're trying to lose, so 480. So that tells me right away that I've got 45 millibars to get to where my target is, because my target is between 460 and 480. So the easiest thing to do that is to say, right, okay, we'll divide 45 by 4.4, and that tells me how much more 6 inch pipe I can put in. So it's roughly about 11 metres. So what we then do is we go 62, because we're taking the 6 inch away. So 62 minus 11 is 51, and 85 plus 11 is 96. So now it's 476. And that's probably the best I'm going to get, because I can't add any more lengths of 4 inch pipe because I would go over, because one metre of 4 inch pipe would take me over the 480. So that's the best I'm going to get, is 476. Okay, so basically we've got 51 metres of 6 inch pipe, and then we're running 4 inch all the way up to design point F. Okay, so that's design point F, so put that in there, DPF. Okay, and then we'll go for design point G, so DPG. We'll do the same again. Now the 6 inch we cannot change. Okay, so we'll put that in. So we'll get 51 metres. We'll get 2 elbows, which equals 2. We've got a globe valve, a gate valve, which equals 1.1. 54.1, 0.65 gives me that. Right. We then need to work out how much 4 inch we've got. Okay, so you've got 5. So we've got 113 plus 15 plus 5. Just let me get a calculator. Helps if you come prepared. So we've got 3 metres rise plus 110 plus 15 plus 5. And that takes me to here, so that's 133 metres. We then take away the 51 metres we've got for 6 inch pipe, or 150 pipe. So we've got 82 metres of 4 inch. Right. Okay. Now, we've got 2 elbows there. So 2 elbows, 2 times 1.1, 1.4, which is a 4 inch elbow. Gives you 84 metres. So 4.4, 317. Okay, we're not finished yet because we've still got 18 metres to go here. So we'll just put 18 metres in here at the moment and see where we come out with that. We've got a 3-inch T because we're turning in that T. Okay. So we go down to screwed, standard screwed T or cross, 3 inches, 4.8 metres, equivalent length. There's 16. So we're up at 773 millibars at the moment. Now remember, we've still got static here. So my static gain is the height between the design points times atmospheric pressure, which is 0.098. So that would equals 0.098 times 6. So that's 0.098 times 6 is 588 millibars. Okay, so we've done that. That's fine. But we've still got 314 millibars loss that we can actually lose. So I'm just going to try something. I'm going to try running it in 65. So put 18 in there, and a 65T would be 3.8. Okay, so we're changing the 80 for 65. Delete that. Delete that. 21.8 meters. 35. So we can see there that we can't run it in 65 because we're at minus. Okay. We'll just keep it 80. So there we have it. We've got 6-inch pipe up to about here. Then we're running all that in 4-inch up to design point F. And then we're running 3-inch pipe up to design point G. And that's how you do it.